So good afternoon. Today we are going to see about the linear integrated circuits, subject related problem statements which supports the both industrial and biomedical applications. So today our students here gathered here to discuss about the biomedical applications. So mainly we use instrumentation amplifier which interlinked with the linear integrated circuits that supports the biomedical signal processing and also many equipments. So today they are going to give a brief explanation about the introduction of that instrumentation amplifier, its pin specifications and its requirement in the biomedical areas, and finally conclusion regarding that topic. So here we go on with the session, the students.
Yeah, before the session, let me give a short intro. So, linear integrated circuits play a crucial role in modern electronic system due to operational amplifiers are the most widely used ICs due to their versatility and stability. Operational amplifiers are used in signal amplification, filtering, and voltage regulation. So, this case study focuses on the design analysis and application of an operational amplifier-based conditioning circuit by using a famous IC741. So, what is the problem statement which I actually taken in this case study? In many real-world applications such as temperature sensing, biomedical instruments, and industrial control systems, the sensor output voltage is very small. That is, the voltage of the output comes in the millivolts. So these low-level signals cannot be directly sent to ADCs or any microcontrollers. So the objective is to make a signal conditioning circuit using an operational amplifier. The amplifier which actually converts a low-level AC into a usable voltage.
So certain linear integration circuit for IC circuit. So reason for selection application is high voltage gain and low impedance appear, high input impedances, low output impedance, and widely available and economical. Next, operations of amplifier configurations used in non-inverting amplifier, high input impedances, and now pass inversion, stable voltage gain.
So here I give a point that they will be specifically using two different ICs. One is IC741, there is a basic op-amp, there is operational amplifier, and secondly for instrumentation amplifier purpose they will be using IC7423. So based on the specifications and applications we can use these two ICs for our requirement.
The sensor low-level output is applied to the non-inverting terminal of 741 operational amplifier, while a resistive feedback network between the output and inverting terminal sets a closed loop gain of 100. AV is equal to 1 plus RF by R1, with R1 is equal to 1 kilo ohms and RF is equal to 99 kilo ohms. A 10 millivolt input is amplified approximately 1 voltage using a 12 voltage supply. The operational amplifier high open loop gain combined with negative feedback ensures stable linear amplification, producing an output signal that is strong and clean enough for reliable processing by data or control system.
ICs have many applications like temperature monitoring systems, and it is also used in biomedical instruments like ECGs and EEGs amplifiers, and it is also used in industrial sensor interfaces and data acquisition systems. ICs have many advantages that it is very compact in size and it is very highly reliable, and it consumes very low power, and it has only reduced amount of noise, and it is very cost effective for mass production, and for the limitations it has a limited bandwidth due to gain bandwidth products, and it is also limited for offset voltage and bias current, and it is not at all suitable for very high frequency applications, and it requires a dual power supply for ICs like IC741.
The resultant analysis of this case study, the designed circuit successfully amplifies a 10 millivolt signal to approximately 1 volt output with minimal distortion. The use of the negative feedback improves linearity and stability. The output waveform remains faithful to the input signal. The conclusion of this case study determines the importance of the linear integrated circuits, especially the operational amplifiers in practical electronic systems by using an IC741. A reliable signal conditioning circuit was designed and analyzed. Such circuits from the backbone of many analog and mixed signal applications. The future scope of the study remains the replacing of IC 741 with low power supply and integrating ADC for digital processing using instrumental amplifiers and miniaturization using ICs based on sensor modules. Thank you.
So here I add two more points that mainly we opt this operational amplifier for mathematical operation like addition, subtraction, integration and differentiation. So it gives the not only the mathematical operation in a proper manner, and also it gives the amplification process for the mathematical operation, and also it is good in gain and stability. So people mainly use this op-amp for this advantages. And one drawback is it can withstand only till 18 voltage. That is the one particular drawback with the op-amp. With this I stop here. Thank you.